Good morning, good afternoon, and good evening, and welcome back to another episode of IT Pro TV. I'm your host, Don Pizzette, back again with another episode of VMware Certified Professional version 6. And in this episode, we are kicking off our section on VMware storage. Getting your storage set up is not the most challenging thing in the world, but it is very important because everything we do is built on top of that storage, and if you get it wrong, it really kind of screws the whole environment up. So we definitely need to have an understanding of how vSphere handles storage, how ESXi handles storage, and how our virtual machines kind of play nice with that. So I wanted to take a little bit of time before we dived into all the configuration stuff to just take a look at how vSphere handles that storage, because it shows up kind of weird. There's some interesting naming conventions and other settings that may look different to you if you've not worked with VMware products before. And so we just need to make sure we got a handle on those for the exam. So that's what we're going to take a look at right here. The main complexity comes from how much support VMware has. That when you deploy an ESXi box, it actually supports a ton of different types of storage. You can have the traditional stuff, right? Like the SATA or SCSI drives. That's what most servers are going to have these days, SATA and SCSI. But you might even have things like eSATA, external SATA drives. You might have old stuff like IDE drives. Well, ESXi will recognize those. And then you might have the fancy stuff like fiber channel host bus adapters, HBAs. And that's where you have all of your storage in a SAN, and your server sees it via what's technically a network adapter, but shows up as a hard drive controller. And then with fiber channel, things can get really weird. You can have things like fiber channel over Ethernet, FCOE, and ESXi supports those too. So there's all these different ways that we can attach storage into ESX, and we just need to recognize how they show up and how we can kind of work with those, right? Now, one of the first concepts that I want to address is just the idea of storage, right? In a typical server environment, you have what's called direct attached storage, or DAS. Direct attached storage is where each of your servers has hard drives inside of it, right? And this is very common. And maybe we have one hard drive that's set up to be the ESX install, right? So that's where VMware ESX is actually running from. And then the other hard drive is set up to store our virtual machines, all right? The virtual machines are going to be stored in what's called a data store. A data store is where your virtual machine hard drives and other things like ISO images get stored. So we typically separate those out. And I say typically, the install actually makes you do it. Even if you only have one drive, it'll still separate them out itself. It'll create a partition for the operating system and a partition for your virtual machines. But it's directly attached to the server. So if I have a virtual machine running here on server 1, and this hard drive fails, what happens to the virtual machine? It goes offline. What if I fail that virtual machine over to another server? Well, the other server has its own hard drives. It has its own data stores, has its own data. So I can't fail that virtual machine over. If I try and fail it over, I need to copy its hard drive too. And if these drives just went offline, that's not an option for me, right? So direct attached storage is fine when you just have a handful of servers and you don't want a complex environment, but it doesn't give you a lot of flexibility. If you want the ultimate flexibility, you don't want direct attached storage. Instead, you want a storage area network, or a SAN. With a SAN, instead of your hard drives being in the servers themselves, you have the hard drives in some kind of an appliance. And there's a number of companies out there like HP and EMC that make these massive storage appliances. And you can put hundreds, even thousands of hard drives in them. And then your servers connect to those drives. Now, the cool part about this is, let's say that this is a virtual hard drive for a virtual machine of mine, right? So I've got a VM created, and let me make it some other color than what it is. So I'll just make it blue. All right. So here's my virtual machine hard drive. With direct attached storage, it would be directly on a server. And if I wanted to fail that virtual machine over, I would have to copy the drive over, which is not necessarily something that's going to happen, right? So instead, if I put that virtual machine drive down here, right? I put the virtual machine drive on my SAN, so it's down here. Server 1 can access it, server 2 can access it, server 3 can access it. They can all access that drive. They can all get at the information. Now, if I want to fail over to server 2, all I have to do is, if the VM is running, we can use vMotion and copy the RAM over, what's in RAM, and then server 2 can access the drive, and we don't even have downtime. But if I had a server failure, if server 1 completely died out, then I'm going to lose what's in RAM. So server 2 can connect and just boot up the virtual machine. Now my downtime is just however long it takes to boot the VM. And now we're back up and we're resilient and we're running, right? That's the advantage of shared storage. There's two challenges with shared storage. First off, when you power on the server, it's not in the server. So how does the server find it? The server's got to have a way to find that storage even though it's not inside the server itself. And then the second problem is with shared storage, what happens if two servers try to access the same data at the same time? Okay, well, it's a short answer. The data gets corrupted. If two servers read the same data at the same time, it's no big deal. But if the two servers try and write to the same data at the same time, the data gets corrupted, it gets damaged, and we lose our data. That's bad. So we have to have a way for the servers to find the storage, and then we have to have a way to make the servers play nice, so that if one server is accessing data, the other server doesn't do it. Okay? Well, the discovery part is actually kind of easy. ESX has it built in, so that when the operating system boots, that it goes and it finds that storage. We set it up so it's in there. And for most of our storage types, we'll define that. If it's fiber like this, though, you put a physical adapter in this server called a fiber HBA, a host bus adapter. And your motherboard, your CPU, your BIOS, they'll actually see that as a hard drive controller. They won't see it as a network adapter. And when they talk to it like a hard drive controller, it'll talk over this fiber and get a list of the drives down here to bring back. So even though the drives aren't internal, the server thinks they are. It thinks that those drives are in the server. And that's pretty cool because, well, I took my virtual machine drive and moved it down here, right? But what if I took my operating system drive? So let's say that this one has my operating system. I could move that into the SAN also. And now this server doesn't have any hard drives at all. When you power the server on, it looks at the HBA, and the HBA shows these two sets of disks. And the server says, okay, I'm going to boot off of this one right here. And it boots up. And then it goes to launch its VMs and it launches them off of here. The server has no hard drives. Now, why would I want to do that? Well, let's say a network adapter dies in this server, or the motherboard, a power supply, a CPU, any hardware component dies in this server. I can take that server out, put in an entirely new server, and it can boot up, see these drives, and I'm back up in business. I'm completely independent of my hardware now. I can completely swap out hardware because the storage is back here on my SAN, right? That's the advantage of going to what's called a diskless install. There's no disks in the server. Everything's on the SAN, all right? But you need an HBA for that. You need a fiber HBA. You can't do that with other technologies, things like iSCSI, right? iSCSI is an interesting one because here, see how I've got these orange lines, and that's supposed to be my fiber HBA running to the SAN. This is a dedicated storage network, a network that's made of fiber optics that runs the SCSI protocol on it. iSCSI takes the SCSI protocol and it puts it on a TCP/IP network. It puts it on a regular Ethernet TCP/IP network and you communicate. It's slower. It's not as robust. And the other problem is, because it's on a TCP/IP network, I have to have a TCP/IP protocol stack running. When your computer boots, it's the BIOS that's kicking in, right? Or UEFI, one or the other. And when those kick in, they don't have a network protocol stack. They're looking for internal drives, so they can't find iSCSI storage. I can't boot this server off of iSCSI storage. It's not possible, right? So if I want a true diskless install, I'm going to need a true SAN, a fiber SAN. I guess it could be a copper SAN. There are some, like the direct attached SANs, but it starts to defeat the purpose. It's usually a fiber optic SAN that gives us that connectivity and the flexibility, all right? But either way, we need to make sure that VMware is properly seeing that storage. How do we know if it's seeing the storage? Well, it's configured inside of the hosts. Let's jump over to my vCenter environment, and I'm going to go into my host and clusters, and I'll take ESX host 01. All right. When I go into ESX host 01, I can go under Manage, and under Manage, you've got storage. And storage is broken up into a couple of pieces, and the first two are the real important ones. The first one is storage adapters, and the second one is storage devices, okay? The storage adapters, those are the devices that let us connect to the actual hard drives, right? So this would be my onboard RAID controller, or my fiber HBA, my iSCSI controller if I've got one. Those are the things that would show up under storage adapters. And then on each adapter are going to be one or more hard drives, and those show up under my storage devices. So these are the hard drives that I'm seeing. Now the naming convention is kind of important. In real life land, you'll have whatever name you want for them, but on the exam, they want you to know VMware's. when you look at the storage adapters, all of the adapters get treated as HBAs, as host bus adapters. Doesn't matter if they're fiber or copper, if they're SCSI or IDE or SATA, whatever, they're all treated as HBAs. So they're going to get numbered that way. They'll show as VM, HBA, and then a number. So virtual machine host bus adapter, and then a number. So you'll see I've got 3 of them: VM HBA1, VM HBA0, and VM HBA32. I don't know why it's 32, it just seems to have picked that. So I didn't name them, it did. And if you look at the different types, I've got one that's SCSI, and then I've got 2 more that are listed as block SCSI, right? Different types of SCSI. The first one is showing that it's on a Fusion MPT Dual Ultra 320 SCSI. The other 2 are showing as PIIX4 for 430TX, 440BX, MX IDE controller. Those are Intel motherboard part numbers, right? So these are the 2 different adapters that it found. And there's potentially devices on each. Now the reality is, one of these is probably from my CD drive, right? And so it's a CD drive. I can't boot my system off of a CD, it's read-only, right? And I can't run virtual machines off the CD because, again, it's read-only. So I might see an adapter in here but not see any devices on it. But one of these other ones will actually have my hard drives attached to it. This server has 2 hard drives in it, one for my operating system and one that I don't think I'm actually using right now. I think it's just sitting there doing nothing. It'll be attached to one of these 2. How do I know which one? Well, the short answer is I don't. I don't know which one. But I can go over here to storage devices and I can figure it out. And here is where I can start to see what's attached to what. And I can see that I'm spotting 3 different drives. Okay, I've got 2 disks, a 40 gig disk and a 512 gig disk. Those are the 2 hard drives in the server. And I've got a CD-ROM. Now the CD-ROM shows up even though I can't actually use it for storage. And if I look at the name is what's important. Here's where it's telling me information about it. These first 2, right? These first 2 disks are both attached to VM HBA1. And if you look at the name, it's mpx.vmhba1, right? MPX is kind of the umbrella name for the storage provider that's built into ESX. On any modern ESX box, all of your storage providers are going to be prefixed with MPX. You'll see that there. If you have older ESX boxes or ones that have been upgraded over and over and over again, so maybe it was ESXi 4 and then you upgraded to 5 and 5.1, 5.5, now you're on 6, you can do that, right? ESXi 6 will run on some of that older hardware. Then you might see other things than MPX in there. For example, on SCSI disks on older systems, you might see EUI, which was the old universal numbering. You might see NAA is another one, or even VML. VML will be really old. I mean, you gotta have ancient ESX for that one. But on any modern system, you'll see MPX. And then the following name is VMHBA followed by a number. So I know that these first 2 are on VMHBA1 and the other one's on VMHBA32. So when I went back to my storage adapters, I had this VMHBA1, that's where my 2 hard drives are, and VMHBA32, that's where that CD-ROM drive is. I've got VMHBA0, apparently nothing's on it. It's very common for you to get a server that has a motherboard with connectors on it that aren't used. You might have an onboard RAID controller, but you still have the onboard regular SATA or SCSI ports that you're just not using because you're using the RAID controller. So don't be surprised if you have an adapter with absolutely nothing plugged into it like I do. All right, then the rest of the name, if we look at it, see how mine are mpx.vmhba1 and then :C00, :T00, :L0, right? What's all that stuff? Well, it's talking about the channel and the identifier for the disk. And so these are both on channel 0, and then we've got T0, T1, right? So basically the first disk and the second disk. You can have more than one disk. On a SCSI chain, you can have up to 15 disks, right? Most people these days are doing serial attached SCSI, so it'll be 1 disk per channel. And if you're doing SATA, you'll have 1 disk per channel too. So you won't necessarily see it like I'm seeing here. Mine's using regular SCSI, all right? So those are the disks that are showing up. And down here I can see that CD, same basic naming, basically following right after that. All right, so those are the existing storage that I'm seeing. And you can do various filters up here. You'll see where you can refresh your layout. You can light up a hard drive. That's useful if you're staring at the front of a SAN and there's 100 hard drives. How do you know which one is which? You can pick the hard drive here and hit the green light and it'll light it up so that you actually see that at status. You can also do some basic filtering. You've got, like here, we can mark them as hard drives. So if it doesn't know that this is a hard drive, well, it knows they're hard drives. See how it shows them as disks? But sometimes it might pick something up as cache instead. And so I could change it and flag it as a hard drive. You've got host cache configuration over here. There's a lot of RAID controllers that'll have 32 gigs, even 128 gigs of flash on the RAID controller to give you accelerated performance. And so it'll normally show up here under host cache like this. You can also have regular disk storage that shows up that way too. So those are instances where something might not show up the way that you expect it. All right, now, what if I want to attach this to a SAN? Well, what I would do is I'd shut the server down, and then I would add the fiber HBA, and I would power it on. And as soon as the system came up, I'd come right in here to storage adapters, and I'd look to see if the storage adapter showed up. Ideally, it'll just show up here in the list if it's supported by VMware. That's kind of important. VMware, they actually have a compatibility guide. If you're going to be connecting to a SAN, you need to make sure that it shows up on the VMware compatibility guide. And you can come in here and search for whatever it is that you have. You can specify motherboards and so on, and it'll look it up and find out whether or not they support it. Assuming your hardware adapter is supported, it'll just magically show up here. Now, I'll tell you, the system detects it really fast, but the graphical user interface doesn't for whatever reason. And so if you look up here at the buttons, you'll see there's refresh this host information, right? So that's just refresh the GUI. That's kind of useful. But over here is rescan the host storage adapter. So if you've added an adapter, you can rescan it so it can pick up the hard drives on the adapter. And then here, this one, rescan the storage adapters. Maybe you've got a server that you don't have to shut down to add adapters. Maybe it has hot swap functionality. And so if you swap one in, you might have to hit this to rescan and look for an adapter that didn't show up. So you've got the ability to do a rescan, and you'll see frequently where like a warning will pop up on your screen saying you really should do a rescan. All right. Let me give you an example of iSCSI. If I want to attach to iSCSI storage, right? iSCSI storage is on the network. So I don't have a regular physical host bus adapter for it. I use my network adapter. And so I can come in and I can configure that. Now, it's never going to automatically find it. I have to add it in. So let me walk through that process. I'm going to go to my storage adapters, and I'm going to add a new storage adapter. If it was a hardware adapter, it would find it on its own. But because this is a software adapter, I have to add it. And you'll see iSCSI and Fiber Channel over Ethernet are both software adapters. So I'm going to go and choose to add it. So it's going to add it to the list, right? So I'll go ahead and do that. And it should show up. There it was, down there at the bottom. There we go. So I just created VM HBA33, and it shows as iSCSI, it shows as online, and it shows my IQN, my identifier, right? So there it is. I'm now connected to iSCSI, right? Sort of. If I look down here at the bottom, I've chosen VM HBA3, and under devices, it's empty. So what I've done is I've turned on iSCSI support, but I need to point it to the actual iSCSI SAN that's on the network. So no matter how many times I hit refresh or whatever, it's not going to make any difference until I actually get in here and configure it to connect. Otherwise, it's just going to sit here, right? So if we want to configure that, for iSCSI, you define what's called a target. And so I'm going to go under targets, and here's where you can specify where your SAN is. And so I'm going to add in a target real quick. And I've just got a simple SAN fired up, nothing too fancy. I'm actually not a fan of iSCSI. I try not to use it if I can ever avoid it, because when you send SCSI traffic over a TCP/IP network, you get TCP/IP's overhead. It slows things down. It's really painful. So iSCSI is great in a test or a lab environment. It's terrible in production. So you really don't want to use it in production. But I'm just using it here as a simple example. All right, so I'm going to punch in the IP address of that server, and it's going to connect. And it's connecting. In the background, my screen has kind of disappeared. There, let me jump back into my configuration. And I'll have to refresh my screen. It's kind of wigging out on me here. So it's going to connect, and we'll see if it gets connected to that target. Now, if you're doing authentication, you'll have to provide a username and a password. I've got mine set up kind of just automatic. And, it didn't turn up. So let's try that again. I'm going to go back to my static discovery here, and I'll add it again. One of the negatives, having a web-based management interface like this is nice because it makes it where you don't have to install software on your machine. But it's kind of a negative sometimes if it crashes out like mine just did. So, so I'm just going to try and punch this back in again. And I shouldn't have to give it an iSCSI target name. Let's just try that one more time. Oh, it is going to make me give it a target name. All right, so I'll call this the IT Pro TV Lab iSCSI. All right, so we'll give it a name, and we'll let it redetect. All right, so it's going to reach out and try and connect to that, and I'll give it just a moment to see if it connects. Now, if I don't see anything right away, I'm actually not worried about that because I might just need to refresh my screen. My tasks here show as completed. You know, I've got this change software, internet, iSCSI status, and it says it's completed. So if there's still nothing showing up down there, I may just need to do a refresh, right? And this is where these refresh buttons come in handy, and it does show up on the exam, where I can rescan my adapters and I can rescan the storage. I don't need to rescan the adapter. My adapter shows up, but I do need to rescan the storage. I'm connected to that device, and if I rescan the storage, it should look for drives that are attached to it. And those drives should show up here under devices when it finds them. All right. Now, iSCSI is not necessarily the fastest thing on the planet, so I'm going to give it just a minute while it reaches out to connect to that, and I might need to refresh one more time. So we'll give that a second. But once it connects, it's going to talk to that SAN, and it's going to say, give me a list of drives. And those drives will now show up under my devices, and we'll actually see them as drives that I can start to work with. With Fiber, you can boot off them. They're there at boot time. With iSCSI, they only show up after the system has fired up its network and made it where it's able to reach out and connect. Now, once it's connected, now we can start to use the drives. And you can't really use the drive until you've created what's called a data store on it. A data store, it's a format. You have to format out that storage to be able to use it. And there's two different formats for data stores. One is NFS, which we're not normally going to use. NFS is the network file system. It's used by Unix, and it's typically used with shared folders. So I might have a Linux or Unix-based server on my network, or Mac OS for that matter, and I might set up an NFS share on it, and I can mount a data store in vSphere to point to that NFS share. And now anything that I put in the data store goes to NFS. Well, that's over TCP/IP. It's over your regular network. It's slow. It's not ideal. It's actually great for storing ISO images. So if you have ISOs, like disk images, you can load them up to your heart's content in an NFS data store, and it works great, right? But you wouldn't want to put your virtual machine hard drives in there. It'll let you, but you wouldn't want to do that. Instead, you're going to want a data store that's actually created on regular hard drives, or SAN drives. And those are going to be formatted with what's called the VMFS, the Virtual Machine File System. The VMFS is a special file system that VMware created that provides support for virtual machines, for vMotion, for snapshots, for advanced disk I/O, all the advanced bells and whistles of the storage system inside of vSphere and ESXi are provided by that VMFS file system. So when we create a data store on the hard drive, it's going to format that hard drive with the VMFS file system, and then we'll be able to actually use it to store things. But we've got to have the drive set up first, and then we'll be able to connect and create it. I actually have my internal drive. I guess I could just use that one instead of waiting on iSCSI. If I jump down to my storage devices, I can see these internal drives that I've got. I've got a 40 gig one that I'm already using. That's where my my operating system is. But I've got a 500 gig drive that I'm not using. It's just kind of sitting there. And so if I want to use that, I could take it and create a data store to reside on it, and now I'll be able to put things in it. We do that on the host, so I'm on the host here. And when we take a look at the host, we need to switch over to our storage view. And so in my navigator over here, see how I'm on the hosts and clusters link? I'm going to switch over to storage. And under storage, I see some data stores that I have. Okay, data store 1, data store 1, what is that? Well, I have two servers, ESX host 01 and host 02. Host 02 is in maintenance mode right now. That's this inactive one. But they both have a data store called data store 1. When you install ESXi, it creates one data store right there on the drive with the operating system. And it's called data store 1. The more servers you have, the more data store 1s you'll have. It gets really confusing really fast. So usually, I don't make use of those. I just ignore data store 1 or just kind of flag it not to use. We're going to create our own. So I'm going to create a new data store in here. And I'll just right click on the data center, and as you kind of look down at the various things you've got storage and new data store. All right, I'm going to create a new data store, and it's going to ask where it's going to go, and it's going in that data center, and then it's going to ask for the type. And here's where I'm going to see NFS and VMFS, right? It needs to know what I'm trying to create. And so as it moves forward, it's looking at the possible options that I have, because if I'm attached to a fiber channel SAN, or if I'm attached to iSCSI, if I have local storage, each one is going to present me with different things, and so it's going to build that up and display it. Now mine is sitting here, probably because iSCSI is timing out. There we go. And oh, I got 3 options. All right, the first one is VMFS. That's the one I want, right? That's the virtual machine file system. It's a data store on a disk or LUN. What's a LUN? Well, a LUN is a logical unit number. When you have a SAN, like if I go back to my crazy diagram here, I have a SAN. A SAN has a bunch of hard drives. When a server connects, how does it tell one hard drive apart from another? Well, each hard drive is given a LUN, a logical unit number. And I keep saying hard drive. It's not necessarily one hard drive. I might have 3 hard drives in a RAID 5 array, or 20 hard drives in a RAID 10 array. And it shows up as one big virtual drive. And that virtual drive gets a LUN. So our server sees it as a logical unit number, a single number. On an iSCSI chain, you can have up to 15 iSCSI hard drives, and they're numbered 0 through 15. 0 is tied up by the controller, so you have 1 through 15 left over. Well, that's kind of how these LUNs work. LUNs actually came from the SCSI world. So that's why it's saying this is either going to be a disk, which would be internal to the server, or a LUN, which would be on a fiber channel SAN or some kind of copper SAN. Then I can do NFS. NFS is that data store over the network. I said that's slow. We don't want to do that unless this is where we're going to be storing ISO images or maybe virtual machine templates. We don't need that often or whatever. The last one is vVol, right, which is a virtual volume. And a virtual volume is a data store that's stored in a vSAN. We'll talk about vSANs in another episode, but you can take one physical SAN and slice it up into virtual SANs. So maybe I've got storage for a DMZ on one SAN, and I've got storage on my other stuff, my internal stuff on another SAN, and I want to combine it into one virtual SAN. Or I have one physical SAN I want to divide into virtual SANs. Either way, and those would be virtual volumes. But I'm going to do VMFS. That's the standard storage, what we're going to use most of the time. Now it's going to ask where I'm going to create it, and I need to pick the host that it's going to be tied to, and mine's going to be tied to host 1. And it's going to look at that host, and it's going to show me any drive that's not currently in use. So my 40 gig drive, that's where my operating system is, that's in use, it doesn't show up. My 500 gig drive, it's right here, it shows up and it's ready to go. And if iSCSI had detected, I would see the iSCSI drives here too, but my internal drive is good enough for me, that's the one I'm going to ride with. It's got 500 gigs of space on it. And so now I'll hit next, and it's going to ask how I want to do it. Now I can use the whole drive, that's the default, or I can customize it and I can specify a certain portion of the drive to use. It's up to me to go in here and change the size, adjust that to whatever it is that I'm trying to achieve. And I can even create more than one data store on the same drive. Not a whole lot of reason to do that. I know you might be thinking, well, I might do that to separate things. Maybe I have a DMZ servers I want to keep separate. Well, when you store virtual machines in VMFS, it isolates the VMs already so that they're in their own directory, but there's permissions and things that are set so that each virtual machine is truly isolated inside of VMFS. It's one of the nice features. So there's really no benefit of dicing this up into smaller partitions. I'll just do the whole thing. When that's done, I'm going to finish it up, and now I'm going to have a data store available, and it's given it the amazing name of data store. Again, one that can be used over and over and completely confused and forgotten. So we might want to change that name or edit it a bit to try and make it something that's a little more meaningful to us. But the default setting there of just data store is fine for me for now. And we can get that put in place, and now we can start to use it. By use it, I mean when I create a virtual machine, it's going to ask me where to put the hard drives. I can choose to put the hard drives right here. And that's going to be where I store it. Now, the problem with the data store that I just made is that it's tied to ESX host 01. It's right here in this machine. If I had clustered storage, that would be better, because now it's not tied to one machine. So you probably noticed when I created that data store, when I right-clicked, I went to Storage and New Data Store. Right beneath it, New Data Store Cluster. That's when you've got storage that's attached to more than one host. Then you can have failover. If you're going to do vMotion, your data store is going to need to be a data store cluster. It's got to be shared between the systems. In my scenario, it's not. I chose local storage, right? If I was connected to iSCSI, iSCSI could be a data store cluster. I can have more than one system connected via iSCSI. If I had fiber HBAs, again, more than one system can be connected. That would be a data store cluster. All right. So that's all going on behind the scenes. And once it's set up, we don't normally have to mess with it, because from now on, whenever you create a new virtual machine, right? So if I go and whip up a new virtual machine and I go to create that, as I create it and deploy it, it's going to ask me where I'm going to store it. And eventually I'll get to a screen. I'm just going to throw some junk in here. And so eventually I'll get to the screen where it asks me to pick my storage. And so when I get to that screen, here we go, select storage, and it's going to show me all the options available to me. And I'll see my fiber storage, my direct attached storage, my iSCSI storage, all listed here, and I can pick where I want that virtual machine to reside. So I might have one fiber channel SAN that is decked out with all SSDs super fast. And I might have another fiber channel SAN that has all SATA drives that are slower. And if it's a mission critical server, it goes on the SSDs. And if it's a regular server, it goes on the magnetic drives. And that way I get tiered data storage. It's up to you and how you define those data stores that make that work. All right. So that's pretty much a good overview. I guess one other thing I want to mention, because this gets confusing, VMFS, it's evolved over the years. Each version of ESXi normally brings improvements to VMFS. ESXi 6 is kind of an exception. So what you used to have, you had VMFS version 3, and then they skipped 4. ESXi 4 used VMFS 3. And then in ESXi 5, they came out with VMFS 5. Well, in ESXi 6, I will say it right sooner or later, we have VMFS version 5 still. All right, so VMFS didn't change between ESXi 5 and ESXi 6, right? So it stayed the same between those two. So even though my environment is entirely ESXi 6, I'm still running VMFS 5. If I ever upgrade in the future to ESXi 7, and maybe they come out with VMFS 7, right? This hasn't happened, but theoretically, then we can always upgrade our data store, and then it'll be in that new file system. But it's usually easier to just create a new data store and move your data over to it than it is to upgrade. The upgrade's kind of a weird process. But that's what I'm seeing here on this screen. If you notice, when I look at my data stores, over here they're showing as VMFS 5. That's what reminded me to talk about that. All right, so that's basically it for data stores on the back end. Just understand that your data stores can be on any number of different types of storage. SSD, magnetic, it can be fiber channel, direct attached, iSCSI, all sorts of options there. Each one has their own pros and cons. You've got to pick the right one for your solution that gives you the performance characteristics that you need. All right, well, that's a pretty good spot for us to wrap this one up. In this episode, we got a chance to talk about how vSphere and particularly ESXi handle storage. We talked about some of the different connectivity methods, and I showed you the screens where that gets set up and how we can refresh the adapters to be able to find out whether new stuff has been added. We didn't actually use it, but that's fine. We're going to use it more in the next episode as we get this configured, especially when we get into clustering, because we need to set up clustered storage that's available to all of our different systems. So we'll get a chance to see more of that down the road. But for now, this is a pretty good spot for us to wrap this one up. So signing off for IT Pro TV, I'm Don Pizzette, and I'll see you next time.